Hello everyone. As a Supernote user, did you ever wish you could have one or more of the following? Have a mechanism to automatically bulk export to PDF, combined with a full backup that only processes modified files and does not require you to go through a cloud provider. Have that bulk export replicate your entire notebook's file structure, which in turn would preserve the external links between these files. Have notebooks recognize text embedded in the PDF, allowing you to perform searches with visual results. Have a PDF table of contents built from your recognized text and the headers in your Supernote notebooks. Have a graphical and auto-indented table of contents in your PDF that is built from the images of the very same headers you created on the Supernote. Have dictionaries that automatically correct words that are consistently misidentified by the Supernote recognition software, and have the ability to automatically load specific dictionaries based on keyword included in the notebook. Have a PDF table of content for the keywords and stars in the notebook. The ability to add colors and styles in the PDF exported notebooks by just including one or more style keywords in your notebook. Export your text-recognized notes to Markdown. HTML with style for headers. Bullet points indentation. Have digest functionalities for PDF without embedded OCR, with more space to take notes in a PDF that merges your annotations in a single PDF, with bidirectional links to and from the digested zones to your notes. And have all these features in a free and transparent open source library that you may be able to customize to fit your specific workflows. If you responded yes to some of these questions, you may want to install PySN on a Windows or Mac or Linux machine. You don't need to be a programmer. The only prerequisite is for your machine to have PySN, which is free and easy to install. In this video, I'm going to guide you step by step on the fastest way to get started with PySN for Supernote in just 5 minutes. Then, I'll quickly go through a list of features and my thoughts about the overall e-ink hardware software media. Are you ready? Let's go. I'm going to do this on Windows 11. But the process is similar for Mac OS and Linux. So the first thing to do is to head to the PySN repository on GitLab. Look for the blue Code button and look for Clone with HTTPS. Copy that on the clipboard. Minimize. Right-click on the desktop. Click Open in Terminal. Type Git Clone, space, and paste the copy of your clipboard. Hit Enter. Close the terminal when the prompt is back. Refresh the desktop. Open that folder. The new folder contains some zip files for various OS. Okay, now let's go back a minute to the GitLab repo and look at the README file. It has instructions for Windows, Mac OS, and Linux. Just make sure that you read the right section for you. One prerequisite, regardless of the operating system, is to have Python 3 and pip 3 installed. Read the instructions to check if your system already meets the prerequisites and head to the Python website to install these files if necessary. See the links below. We're going to assume that you have these files already installed. Okay, the next step for us is to set up the virtual environment. That's the container of libraries that Python script needs. This installation part requires you to type python setup_venv.py. We can click on this button to copy the command. For Mac OS and Linux, it's Python 3. Okay, let's go back to the PySN folder. Open a new terminal there. Paste the contents of the clipboard and hit Enter. The libraries are being downloaded and installed automatically. For you, it may take more time because pip 3, the installer, is going to have to download everything, while in my case, it is using cached copies. Okay, it looks like it's done. You can see that a shortcut has been created to launch PySN from the desktop. All right. I'm going to move it to my desktop. Now, let's get some settings match your Supernote contents. For that, head to the SN Vault folder and open usersettings.json with a text editor. The input parameter contains a list of folders to process. All the default folders are listed. Also, regardless of your microSD card name, if you want PySN to process contents of the microSD card, you have to prefix these folders by SD card. The asterisk indicates that the entire folder structure is going to be processed. If you don't want an entire folder tree to be processed, you may indicate a specific folder, but don't forget to end its path with a /. The folder names are separated by a comma, and there is no comma at the end of that list. Keep in mind that one reason to convert an entire folder tree is to keep the external links between notebooks. Output is where the modified digest, PDF, and marked files are being uploaded on the Supernote. Converted designates the folder where the converted notes will be stored. Let's not touch it for now. Backup designates the location of our backup files. We'll come back to this later. Digest holds the substring that needs to be included in the path of files you want PySN to digest. Export is where the merged digested files are uploaded. Don't worry about all these for now. However, you may want to replace auth with your own name, as it will be used to designate the author in the metadata of an exported PDF. Now, this is important if you want to communicate with your Supernote through the Browse and Access port. The web IP parameter needs to match the address of your Supernote. Lastly, syncf is the mirrored folder of your cloud solution. You only need this if you don't use a USB cable and you do not want to transfer through the Supernote web server on the local area network. I left, as an example, my own settings for OneDrive. Feel free to replace by your own path. All right, let me revert back the input settings of Notes so that we get the entire Supernote file structure of notebooks replicated on the PC. That was a lot. But you won't have to change these settings often. In most cases, you'll just run the script by double-clicking on the shortcut that was created, all right? Okay, save and close that file. By my count, it's been 4 minutes and 27 seconds. Mission accomplished. Let's launch the program by double-clicking the PySN shortcut. Okay, you can see that the script has opened a terminal and is running in the background. My Supernote is connected via USB and was found by PySN. So PySN is using that communication mode. If it did not find it, it would have tried to locate the Supernote on the local area network using the Browse and Access channel. And if that failed too, it would have used the mirrored folders of our cloud synchronization choice. Okay, I've put the terminal side by side with the Windows Explorer to show what is happening. You can see that the folders that were listed in the input settings are being parsed. PySN creates a hash signature for each file and stores it in a registry. That signature is used to check if a file has already been processed or not, for future conversions, backup, or digest. Note that PySN won't work directly with your files. It always creates a temporary local copy, here under the _sn_local folder. Okay, we can see that the script has computed 251 file signatures that are going to be stored in a registry. It will now start to convert notebooks and digest pairs of PDF mark files as long as they are in a path containing our digest setting substring. So let's wait for the program to finish. In my case, that's about 1 GB of notebooks on the internal drive and a bit more on the micro SD card. PySN automatically switches to an idle mode when it deals with many files. It will take some time at first, but subsequent runs will filter out processing of unmodified files, all right? Okay, PySN ended. Closed the terminal and reverted the shortcut icon to black. To illustrate subsequent runs, let me first modify a notebook. I'm editing this project's notebook. Let me rerun. Like before, PySN is parsing, checking the file's signatures. In this case, there were only 5 changed files. Likely the digested files that were re-uploaded to the Supernote Plus our modified notebook. Again, PySN closes the terminal and revert the shortcut color to black when it's done. All right, time to look at the long-awaited outputs. On the computer side, besides the temporary _sn_local folder, we see 2 other folders. Backup_notes for our backup and exported_notes for the converted notebooks. On the Supernote, the digested files were re-uploaded as a modified pair of PDF mark file and a merged PDF. In our settings, we left untouched the default settings for these paths. In another video, we'll change these settings to have the converted folder at another location and the backup folder to match the local folder of the Supernote Partner app, since some users may want to use the Desktop Partner app without using the Supernote Cloud. Just also quickly, missing links contains details of broken external links. Registry contains the file signatures. This is needed to avoid reprocessing unmodified files since last run. but feel free to delete it if you want to start from scratch. We saw user_settings before. This is the file you can edit to change your settings. There is a command line interface, but that's beyond this video. We want to keep things simple, don't we? Okay, the backup files. Nothing fancy here. You run PySN and it pulls your files from the Supernote. When a notebook is modified, the older version is UTC datetime stamped and moved in an old folder. Maybe we'll implement something fancier later to compress old archives and restore. But as of today, keep in mind that you'll have to manage the growth of the folder yourself and remove the datetime postfix if you want to restore an earlier version. So here, for example, is the notebook we just modified and its earlier version in the old subfolder. As I mentioned before, PySN uses hash signatures to identify any new or any modified file. That's how it knew to tag the earlier version of this file and skip the unmodified files. PySN uses the same mechanism to know what file to convert. Alright, that was it for the backup. Before looking at the cool stuff, let me clarify again that PySN is a console app that just runs a script and outputs some files. It is not an interactive app to view and edit files. Our philosophy is that there are better tools that everybody uses to manipulate outputs, a file manager, and, most importantly, a good app handler for files in the exported format. So, the usefulness of PySN will greatly depend on the tools you use to interact with these exported formats. For PDF, I personally use Adobe Acrobat Pro for work every day. But let's say that you are on Linux and that you can only have a basic PDF viewer. Some of the file features introduced by PySN may not be usable, and you won't get the same benefit that I get. Makes sense? Alright, enough lollygagging, let's look at the converted notebooks. By default, the exported root folder is also under sn_vault and is called exported_notes. But again, you can change the location in the settings and have PySN output them to a folder of your choice, such as a Google Drive folder, where you may decide to share some subfolders with other people. Okay, onto the note folder. Remember that we added an asterisk for that folder in our settings. This means that the entire file structure is replicated, but this time for converted notebooks. Let's go to the coding folder, where we modified PySN lib. This project's notebook. What do we have here? Like we saw for the backup, we do have here the same notebook names, but they are obviously converted to PDF, .md, or Markdown files and HTML. Let's open its PDF to illustrate the advantage of bulk exporting and preserving the file structure. On page 22, we have a link to an external file, as we can see with the security warning popping up when clicking on it. Let's allow the access, and voila, it opened the other file, like in the Supernote. Now, when you do that on the Supernote, you have the cool backlinks to come back to the file and page with the original link. To preserve the same functionality on the bottom of the landing page, PySN added a link to the page of all workbooks referencing this page. So clicking on it sends us back to our PySN lib notebook. Pretty cool, huh? Okay, let's talk about exporting the recognized text from handwritten notes, and more specifically the text recognized by the device. While the Supernote allows you to export the recognized text for each page, it currently doesn't include it in the PDF. Also, even though coordinates of each recognized element is currently stored in the binary file, the Supernote outputs and exports the text without its spatial layout. In contrast, PySN uses that information. Before moving on, let's briefly talk about dictionaries that you can use with PySN to correct words that are consistently misidentified by the Supernote text recognition engine. A dictionary in this context is just a file listing pairs of misidentified words and their correct equivalent. PySN will simply replace well-known misidentifications you listed in dictionary keys by their correct values. A dictionary also allows you to create shortcuts. For example, ironically, the Supernote can't recognize the word Supernote from my handwritings. So after a numerous key-value pairs, I resorted to add the SN key for the value Supernote. Since SN is usually flawlessly recognized, I remember this and type SN for now on. But what if tomorrow I have a notebook with SN referring to social network? Good question. The answer is that, in addition to a main dictionary, PySN will load specific dictionaries based on keywords found on the notebook, so I will only include a Supernote keyword in Supernote-related notebooks. The order these dictionaries are loaded also gives you some flexibility. We'll see in the example that the main dictionary includes tilde as a key and space dash to designate a Markdown sub-bullet point list, something that I personally found impossible to create on the Supernote. Alright, now let's see some concrete functionalities examples using the enhanced text, meaning the recognized text plus the dictionary corrections plus the text spatial information. Let's first illustrate how including that information in the PDF allow visual searches. In the same notebook, let's search for the word hash on the Supernote. We find 2 matches. Unsurprisingly, we find 2 matches on the PDF, too. But look how the searched word is superimposed. Pretty neat, right? Technically, the words are placed on another layer and superimposed. I can show this by selecting the content of the PDF page, copy and pasting it in a notepad. Okay, back to the recognized text. Another functionality is getting a PDF table of contents. By intersecting recognized text with header's spatial location, we can infer the text attributable to a header and create, for each page, a series of bookmarks. Let's come back later to those red groups of bookmark that you see at the bottom. While we are on the table of contents topic, see that little blue caret on top of each page? Let's click on it. PySN generated a graphical table of contents in the PDF and appended it at the end of the file. This feature doesn't use recognized text. It's the equivalent of the built-in TOC you have on Supernote. But unlike the Supernote TOC, it keeps the header's style, it indents, and it's bidirectional. You can indeed click on any header in the PDF to see where it is located in the TOC, giving you more context. Okay, back to the recognized text. With the style information we gathered from our notebook's header, let's see how we can add some style to the better recognized text and have much smaller outputs in size than the PDF format. Markdown and HTML are 2 such formats. PySN has a very basic Markdown. At this time, the links aren't included yet, and the code needs some improvements. Let's take a look at our same notebook Markdown file. Let's open it first in the notepad. You can see the simple headers with a number of hashtags. We can also see the bullet point lists and indentation for the sublists, thanks to the dictionary that properly converted the tilde. Let's open the file using a Markdown viewer. This one has different themes, like GitHub style or dark. I know that a lot of folks in the community use Obsidian with Markdown files. I haven't taken the plunge yet, but PySN settings would allow you to have the exports in Markdown land in your Obsidian vault. Now let's briefly look at HTML, which is a more popular text tagging format. In PySN, there is a very basic Markdown to HTML function. By the way, let's give Claude Sonnet 3.5 the credits for that function. So why would you need that output format of your notebook? Well, besides being very popular and rendered by all browsers, you can easily apply more elegant styling using a CSS file. In PySN, all HTML in the export tree folder refer to a relative CSS file at the root of the export folder. See the header of the HTML here? That's how your browser knows that the CSS file is 2 levels up. Here is that CSS, and you can see that I highlighted in red elements of a sublist, just to make my point on styling flexibility coming from the dictionaries. Now enough geeky talk, let's open it in the browser. Let's scroll to show the rendering of the recognized text versus the actual Supernote handwritings. Note that I styled the CSS to be close to the Supernote header's style, but you can easily set it to a style you prefer. Just edit the CSS file, and let's show side by side the PDF, Markdown, and HTML. Let's scroll a bit more. All right, now let's take a minute to talk about what I believe is an important feature of PySN. Keyword settings, a mechanism to apply some specific settings at the level of a notebook. Not the general settings that we saw before when editing the user_settings file, but specific settings for a notebook by just including specific keywords using the Supernote interface. Dictionary affectation is a special case of keyword settings, since PySN loads any dictionary based on the keywords used in a particular notebook. Except for dictionaries, keyword settings, or KS, need to all start with KS-. They are followed by a category description, another dash, and an optional file name root used to locate a JSON on the disk. At this time, we have the following categories: color, to convert colors of PDF files; Copy to save a specific notebook export at other specific locations. Dictionary to load a dictionary. In addition, we currently have Boolean KS, meaning KS that do not need the file name because their mere inclusion in a notebook is a flag that turns on a feature. For example, KS-vector will export the PDF with vectors. We also have KS-embedded style that I will illustrate shortly with an example. You can see KS keywords under the settings subgroup of the keywords TOC. They are grayed out because they aren't about content, but rather about styling and defining settings. Don't worry if all this sounds a bit too abstract now. We'll see some concrete examples. Just remember that keyword settings is an easy, original, and powerful way to customize settings at a notebook level, okay? All right, back to our HTML export, and let's illustrate a use case of KS with KS-embedded style and a KS-copy-cloud keyword settings. Let's break down the KS-copy-cloud. KS- tells PySN it's a special keyword belongings to the settings. Copy tells it to make extra copies of the exports based on a JSON file called copy-cloud.json that I have created here. Including this keyword in a notebook tells PySN to make an extra copy of the converted files for each of the keys in this JSON, except the PySN usage key, that is informational in case you forget how to change these settings in the future. So basically here we are instructing PySN to make an extra copy of the exports to OneDrive in the following location and another to Google Drive at that other location. Are you starting to get the flexibility that keyword settings bring? You could, for instance, only have your team meeting notebook going to a shared OneDrive to be available to your colleagues whenever you run PySN. Now, what about KS-embedded style? We saw that the HTML outputs are using a CSS file at the root folder. If you ever created web pages, you know the power of CSS files. They uniformize the entire website style because there is an instruction in a specific page that tells the browser to render the page based on the styles defined in the CSS file. So what does KS-embedded style do? Well, it basically extracts styles from the CSS file and applies the applicable styles to every single element in the HTML. Wait, what? Why would someone do this? Isn't it defeating the purpose of having a CSS file and against all HTML design 101? You're right, it creates an extremely crowded HTML code. The only reason we implemented this is because we want to use HTML to docx converters that don't work well with CSS files. So let's add these two keywords to our PySN lib notebook and rerun PySN. Since those are keyword settings, it doesn't really matter what page I attach them, and I can select any word to get to the keyword insertion interface. For instance, let's select 15. Let's add KS-copy-cloud and KS-embedded style. Okay, I closed the notebook and navigated to my Google Drive without showing all my folders. This is one of the mirrored cloud folders that we designated in the KS-cloud-JSON. All right, it's showtime. Okay, it's done. Let's head to the Google Drive folder. Just a quick check to show the keyword settings in the table of contents. They are here indeed. Open it with the text editor. Yeah, that's an ugly code. But let's open it this time with Google Docs and export to Word. Now, Google Docs doesn't appear to respect the paddings we had on our style. So what we could do is create another CSS without the dark background for the headers. Okay, I quickly modified the CSS here, removed the background, changed some colors, resized the headers. Now, if I just rerun PySN, nothing will happen. Can you guess why? See, we modified the CSS, not the notebook. From PySN's standpoint, our notebook is processed. So let's make a change here to have a new file signature. Well, I think I'm wrong and today is the 23rd, but it doesn't matter for what we're trying to accomplish. One thing though, I realized recently that there is a Supernote cloud synchronization bug that erases previously recognized text. Supernote support team will address this. Let me just quickly check that that's not the case today. All right, folks, one more try. PySN, then Google Docs, then export to Word docx. By the way, since I overwrote the main CSS used by all the HTML files, you can see that the new style is applied to all the exports that we have. So for example, this is how another notebook's HTML export is rendered. Okay, that was it for keyword settings. It's not that complicated to customize to your preferences. You can edit these JSONs in a notepad, but keep in mind that you do have to respect the syntax. If you have any trouble, ask on GitLab or Reddit, okay? And if your creativity produces nice styles and amazing workflows, don't hesitate to brag about it and share, all right? Now let's briefly talk about PDF annotations and the digest feature. Very briefly, because we have another dedicated video on the features. Here we have an academic paper in a PDF format with some handwritten annotations, some highlights, some just with color or underline, some others with comments. Technically, on the Supernote, none of your annotations, not even the highlights, are made directly on the PDF. Instead, they are made in a separate file with a .mark extension. So basically, the annotation is a pair PDF plus mark files. The mark file is like a notebook that is superimposed over the PDF. When you export your annotations, the Supernote merges the two files in a single PDF that you can also choose to annotate, but your previous strokes cannot be edited anymore, okay? When you annotate a PDF in the Supernote, you also have access to a digest feature. Basically, digest allows you to select and extract text information from the PDF and to add handwritten notes about the extracted information. Behind the scenes, though, this is a separate app. The selected data and your handwritten notes are not stored in the mark file or the PDF. You can export the digested sections to PDF, and since the last OS update, you can create external backup of these files. You have a link between the pair of PDF mark and the digest files on the Supernote, but you don't have any links once you export. The annotations merge the PDF plus mark notes in one PDF and the digest exports to another PDF. Also, since the digest works by extracting text from the PDF, this feature is only available for PDF files that have OCR content. It won't work for PDF just made of scanned pictures. Let's illustrate, with another file, how native digest poorly handles graphics or tables. The extracted data is either missing or misformatted. One last limitation here is that, for some reasons, the Supernote doesn't recognize the text for your handwritten annotations, including those in the digest sections. Okay, that was for the Supernote. What does PySN do differently? PySN basically unifies annotations and digest functionalities. All the information is either in a merged PDF or a pair of PDF plus marked file. There isn't any data stored separately, like in the Supernote's Digest app. PySN's digest functionalities are also different. Let's go over them. First, since PySN doesn't run on the Supernote, but on your PC, you have to select the areas you want to digest. In PySN, this is done by highlighting, circling text with a predefined color, by default light gray, while the white color is the default color to erase. PySN then creates bidirectional hyperlinks between these zones and a note-taking area that is appended at the end of the PDF, and re-upload the modified PDF to the Supernote. PySN's digested areas are not extracted text, but cropped pictures, allowing you to have digest functionalities also for PDF without OCR, and allowing you also to preserve formatting such as formulas and charts that appear unreadable when using Supernote's digest, because the extracted text is not formatted. Number 2, PySN has an optional text recognition for your handwritings using Microsoft Computer Vision, which in turn allow you to search your handwritings. It can be turned on using the MS Vision setting. You'd need to provision resources with Microsoft Computer Vision, but let me tell you that it is very good. fast, and super cheap like free for the first 5,000 monthly API calls. I may do a video showing how to get this running in less than 5 minutes. Once you do, all PySN needs is for you to store your API key and resource URL in an environment variable and turn on the setting called ImsVision. Number 3, PySN will append to the table of contents a digests category and a last annotations category where your highlights are sorted. Number 4, PySN also repurposes the white color to erase sections of the PDF or previously created digest links. Number 5, PySN also removes the selection strokes by modifying the .mark file and re-upload a pair of modified PDF plus modified mark for those who may still want to modify their strokes, while keeping the added hyperlinks between PDF areas and their corresponding digested sections. Note that you need to store your files in a path that includes a digest keyword. By default, it is digest_in. Okay, all this may still appear too abstract. So a quick example. As mentioned before, PySN digest requires repurposing some pen or marker colors to select areas of the PDF you want to digest and erase some other areas. By default, the light gray color is used for selection and the white color is used to erase. To show all features, let me set the ImsVision setting to true. And let's also set the debug setting to true to show that PySN is processing images. Save these changes. You don't need to use the digest features to have your annotation merged. But let me select some to show you what PySN does, okay? Let me first redo this circling to include my note since I have already some annotations in this document. PySN assumes that the annotations inside or in the vicinity of a selected area are part of your comments to digest. We'll see that PySN will move such handwritings. Let me add a few more. Oh, and let's get rid of this dark screenshot that I can barely read. Just a few more formulas, tables, and graphics. Let's do the same in the other PDF file. Also, let me erase the previous outputs. Let's launch PySN. You can see in the terminal that the script is handling annotation pages and is submitting some images to Microsoft. Note also that we voluntarily insert a delay here to avoid triggering any rate limit by Microsoft. FYI, it's not only the handwritten text that is recognized, but also the cropped image. So if we were, for instance, annotating a scanned book in Latin, without OCR, you'd be able to also search for the Latin words in the digest. Since we are in debug mode, you can see that PySN is extracting and recomposing images from the PDF and from our handwritings. Pictures recognized text are cached for future script execution, ensuring that only new images generate an API call. Here is the dictionary of cached recognized text by Microsoft Computer Vision. All these bits of images and data are stored in a timestamped temporary folder that is deleted when the script execution ends unless you activated the debug mode. All right, it's done. Let's take a look at the outputs. First, the single PDF obtained by merging the original PDF and the mark file. This is the equivalent of the Supernote PDF export. From our settings, this output lands in the export/ignore folder of the Supernote. Let's compare the side-by-side the input with the PDF output. PySN has also already updated the contents of the backup with this file. Note that our selection strokes have been replaced by a rectangle snapping around the text, and our handwritings that were inside the selection are gone. That caret indicates that data is available next to it, so tapping on the rectangle sends us to the digested area that PySN appended at the end of the PDF. Our handwritings that were next to the digest have been moved there already. They are not strokes, but we could still erase them using a white pen or marker. The links from the selections are bidirectional. Tapping on the cropped image sends us back to the original area of the PDF. Now, what's the purpose of this caret? There isn't any rectangle next to it. Well, it's there to indicate that this particular highlight has a comment. Most PDF viewers would indicate that with a bubble icon, but the Supernote doesn't, without navigating to the Highlights menu. Since this PDF is meant to be further annotated on the Supernote, PySN adds the caret. Let's go back to the input file and scroll a bit more. And here comes our erased area and its corresponding free space. Since we have cropped images, we don't have any issue with formulas, tables, and graphics. Now let's look into the table of contents. This document came with its own table of contents. On the right side of the screen, we see that PySN added more categories in red: digest, last annotations, and keywords. Let's expand the digest. We can see that we have bookmarks for pages with digests. Clicking on one sends us to the original PDF area. Last annotations is meant to gather date-time sorted annotations. It still needs some work. Keywords gathers the keywords, including the keyword settings. Note that since digest uses 2 colors, output color customization for the digested files is reduced to 2 colors instead. All right, let's take a peek into the other PDF document. First, you can see that the handwritten text is red as we added a KS color red keyword setting. Let's scroll a bit. Now, let's search for a handwriting, like mama, which I presume only appears in my handwritings. Let me also quickly load the output on the Supernote to show the same search. It was found, and now for the word distribution. Okay, searches work. Now, let's navigate to the second type of output. In our settings, we directed PySN to upload them to the document/pdigest_out. We can see on the folder that for each document, there is an associated mark file. In other words, I'm going to have to open these in the Supernote. Let me take a screenshot of the input first page to compare. Okay? We have on the left the second output loaded on the Supernote, and on the right a screenshot of the input. On the left side, this isn't just a PDF, but a superimposition of a modified PDF and a modified mark file. That's right, we had to remove the selection strokes that were in the .mark file. To prove it, let me cut some handwritten notes and head to the handwritings area using the hyperlink. Now, we already have some frozen handwritings here, but we can erase and paste the strokes. We could also copy and paste the other strokes that were not moved, or delete them altogether. This video has been a side project over the course of more than a week, so I forgot to mention 2 more features. First, the table of contents also has a group of bookmark stars. PySN group and sort pages by stars number, allowing you to mark some pages as more important than others. For instance, here are the pages with 3 stars, then 2 stars, then 1 star. Second, PySN stores some information in the PDF metadata, allowing your operating system or other software to index files based on metadata content and make searches. You can see in the document properties that it has the keywords, the author name, the original path of the source notebook on the Supernote, but also some custom metadata for future script allowing to recreate external links if the PDF files are moved to another folder. The big picture. All right, we saw some cool features, but let me step back for a second, use a macroscope, and share my thoughts about what this Supernote PySN combination brings to me. Being able to scribble thoughts, revisit them, format them with headers, have a reliable text recognition that allow myself, my colleagues, and virtual assistants to immediately grasp what I was able to write down. This mix gives much more than the ability to search keywords. It gives me the ability to data mine using much more complex tools such as AI and quickly re-understand my thoughts. Similarly, this visual plus logical media would help colleagues better understand ideas I wanted to convey. I may later on leverage web apps that I have already built using agents, but I haven't done so for PySN yet. But let me quickly illustrate my point using Adobe Acrobat AI module. This is a paid add-on in the Adobe Acrobat Pro subscription. So let's open again this project's PDF and let the AI ingest it. This is by no means a large notebook, but let's assume that I have this notebook with extra copy to a public Google Drive folder and that you want to know more about PySN transfer types. Let me type a question. And another about keyword settings. To summarize this point, the text is obviously critical to data mine, but the magical sauce is also getting the response that includes the way I formatted my thoughts with the extreme flexibility of spatially arranging words, sentences, the size and style I used. From a technical standpoint, I am convinced that in the very short future, most software tools will be able to analyze pictures and grasp the richer nuances, beyond just text. That's enough for this video. I hope PySN will help you enhance your own workflows. Its original way to handle settings through keywords opens the way to more possible use cases. Pick what you find useful and please let me know your thoughts in the comments. In the meantime, happy writing.